we are going to learn how to factorize polynomials or factorization of polynomials. So this is our topic. Now for factorizing any polynomial, we first need to understand what is meant by factor. A polynomial gx is called a factor of the polynomial px if gx divides px exactly. So these is known as factor. So gx is a polynomial and p of x is another polynomial. So gx could be called a factor of px only when gx divides px exactly. So x minus 2 is a polynomial and x cube plus 3x minus 10 is also a polynomial. So x minus 2 can be called a factor of x cube plus 3x minus 10 only when x minus 2 is when x minus 2 divides x cube plus 3x minus 10. Okay, so we can say that x minus 2 is a factor of x cube plus 3x minus 10. In this case, in this example given, x minus 2 is already a factor of x cube plus 3x minus 10. If we work it out by long division method, we can see that x minus 2 is a factor of x cube plus 3x minus 10. Or even if we use factor theorem, we can find that x minus 2 is a factor of x cube plus 3x minus 10. So we can say that x minus 2 is a factor of x cube plus 3x minus 10. So this is the concept of factors. Now comes factorization. Now factorization is basically expressing a given polynomial as the product of its factors. So now to understand this concept of factorization very easily, let me take numbers first, constant numbers. Let us take for the number 16 for example. Now by prime factorization, 2 8s are 2 4s are 2 2s are 2 1s are. So 2 2 2 and 2 are the factors of 16. Now it is a perfect square, that is why it is the square root is 4. Now let us take 18. So here it is 2 9s are 3 3s are and 3 1s are. So here I can say that 2 and 3 are the factors of 18. This is similar in algebra. In algebra, instead of taking numbers, we factorize the algebraic expressions. Now while factorizing, we must remember some formulas. First is a plus b whole square equals to a square plus 2ab plus b square. This is the first identity. Second is a minus b whole square is a square minus 2ab plus b square. Third is a square minus b square equals to a minus b and a plus b. This a square minus b square is the most important identity which we will be using in middle term factorization, about which I am going to say a bit later. So now first let us work with these only three identities. First is a plus b whole square equals to a square plus 2ab plus b square. A minus b whole square equals to a square minus 2ab plus b square. And a square minus b square equals to a minus b into a plus b. So these are the three identities or three algebraic identities which we must keep in mind while factorizing a polynomial. Now, first method of factorization. Methods of factorization. Methods of factorization. First is factorization by taking out the common factor. So this is the first method which we are going to follow for factorizing a polynomial. So first is 5x square minus 20xy. So this is a polynomial which is given to us. Now in this case, I know that 5 is a multiple, or 5 is a factor of 20. It is because 5 into 4 equals to 20. So I take 5 over here. I will check for the variable which is common in both the terms. In this case it is x, and here it is also x. So I can take a 5 common between them, and then I can just write rest of the terms remaining inside the bracket. So 5x square. So 5x into x minus 4y. This will be the factorized form of 5x square minus 20xy. So see, again observe what am I doing here. First I am going to check if this is a factor of the other term or not. So 5 is a factor of 20. So I write 5 over here. Then I take an x, because x is common in both the cases. It is x square in here and it is x in here. So I take an x. Then inside the bracket I write x minus 4y. If we again multiply it, we can find that 5x into x is 5x square minus 5 into 4 is 20xy. So 5x square minus 20xy's factorized form is 5x into x minus 4y. Now let us take another example. 36a cube b minus 60a square bc. Okay, in this case, see, 36 is not a factor of 60. So we will take the common factor between them. Here I can write this as 12. 36 is divisible by 12 and 60 is also divisible by 12. So 12 is a factor of 36 and 60 or 12 is the common factor between them. Now let me check with the variables. Here it is a cube and a square. So the maximum degree of variable which I can take is a square. Then comes b. B is common in both of them. So I again write b. But C is not there in the first term and only it is there in the second term. So I cannot take a C, because if I take a C over here, then when I will write in the bracket 12 3, then this expression would become 36 a cube bc. But this is not given in the question. In the question it is given that the first term is 36 a cube b. So I am not going to take a C. Alright. So now inside the bracket we write 12 3s are 36. So then a 3a minus 12 5s are 60. There is already a square b and a square b is there, right? I write 5c, because 12 5s are 60. Now keep this in mind that the terms which are inside the bracket should be in their lowest terms. In this case I could also have written this as 3. I could have taken 3 outside the bracket, and inside I could have written 12 minus 10, but 12 minus 10 could also be again factorized into lower terms. So I took 12, and which in turn resulted in the lowest term of the algebraic expression inside the bracket. So this will be my main objective. And again, be sure that you take the variables very carefully. A cube b. Why am I taking a cube b? It is because here it is a cube and here it is a square. So the highest degree of a which I can take is 2. It is because if I take 3 over here, then it will be alright with the first term, but there is not a cube in the second term, which is 60a square b. There is a square. If there was a cube in this case, then I could have taken a cube b. But as there is only a square bc in this case, so I am taking 12a square b, 3a minus 5c. Then let us again take another example. 5a b plus c inside bracket minus 7b b plus c. Now observe in this case. In this case, b plus c and b plus c is common, and 5a minus 7b is common. So I directly write the answer as 5a minus 7b and b plus c. This is the simplest form. B plus c and b plus c is common. I take b plus c in one bracket and write 5a minus 7b. So these are the three examples of factorization by taking out the common factor. Okay. Now let us do about factorization by grouping. Factorization by grouping. Next comes factorization by grouping. Factorization by grouping. How to factorize by grouping numbers? Now, AB plus BC plus AX plus CX. Here we will be usually given with 4 terms, out of which we will have to factorize it. Here observe AB plus BC and here AX plus CX. Observe these two terms very carefully and try to find out the common factor between them. In this case, AB plus BC, B is the common factor between them. So I can take B as common and write A plus C, right? Again plus, here X is common, I can write X into A plus C. Now I have to make sure that the terms inside the brackets must be equal. Then only we can factorize by grouping. So A plus C and A plus C is equal. So the factorized form will be B plus X into A plus C. This will be the factorized form of AB plus BC plus AX plus CX. So this is known as factorization by grouping. Again, let's take another example. Next is x square plus 3x plus x plus 3. Here x square plus 3x and x plus 3. In the first case, I can take x as common, but I am going to take only x, not x square, because in only the first two terms, x, if it was x square, then it would have been 3x square. So I am not going to take an x square. So x plus 3, I write this. Now in this number x plus 3, what is common? 1 will be common, because 1 into x and 1 into 3 is equal. So if I write plus 1 into x plus 3, I can write this, then I can also get my desired number. So x plus 3. So then x plus 3 and x plus 3 is common. I can write x plus 1 into x plus 3. Now you have to practice much more to master this ability. So that's it for today. Thank you. Please like, share and subscribe the video.